Okay, now we'll see some mean value theorem. Specifically, in examination point of view, we'll see Taylor theorem and Maclaurin theorem. So, let us take a function f of x plus h. Okay, this function, this f of x plus h is a function of h. X is an independent variable, it doesn't have any relation with x. F of x plus h is a function of x, h, and it can be expanded in the powers of h, and it can be differentiated any number of times. Then I can write f of x plus h is a function of h, and it can be expanded in the powers of h, and it can be differentiated any number of times. Then I can write f of x plus h is equal to f of x plus h into f dash of x plus h square by 2 factorial f double dash of x plus h cube by 3 factorial f triple dash of x, and so on. Now let me put a corollary. This corollary will be useful when we go for next theorem. Corollary is wherever x is there, you substitute a. Then f of a plus h is equal to f of a, which is equal to f of a plus h f dash of a plus h square by 2 factorial f double dash of a, and so on. Now, what is this Maclaurin theorem? Substitute for a is equal to 0 and h is equal to x in the Taylor's theorem, you will get f of x is equal to f of 0 plus x f dash of 0 plus x square by 2 factorial f double dash of 0, and so on. This is the Maclaurin theorem. Shall we go into problems? So actually, if you want to know something more about that, Taylor's theorem and Maclaurin theorem both fails when the function becomes either function or the first derivative of the function. You see, this function or the first derivative of a function or second derivative of a function, anything has become infinite, then this series, this theorem miserably fails. This is applicable to both Taylor and Maclaurin theorem, but it is very useful in expanding series. Let us see one example now. There is one series given, f of x is equal to x cube plus 8x square plus 15x minus 24. Now what they are asking, the question is find out the value f of 11 by 10 using Taylor series. See, f of 11 by 10 can be very well written as f of 1 plus 1 by 10. So this is in the format f of x plus h, which is nothing but x is equal to 1, h is equal to 1 by 10. So how you will expand this type of series? F of x plus h into f dash of x plus h square by 2 factorial into f double dash of x. So what you have to find? Take the function f of x, find out the first differentiation, 3x square plus 16x plus 15. find out the second differentiation. Whatever you require, you find out. 6x plus 16. Find out the third differentiation. 6. Substitute all these things in this. So what will be there? Now f dash of x is now x is 1. So this will be 34. This will be 6. So what happens in this case? Plus 16. This is 22 and this is 6. So substitute here. Now f of x is 1. F of 1 is 1 plus 8 plus 15 minus 24, which is nothing but 0. Plus h is 0.1 into f dash of x is 34. Plus h square is 0.01 by 2 into 22 plus 0.001 by 6. 3 factorial is 6 into 6. So you will get something like 3.511. So this is how we solve the Taylor series. Now we will see one question in Maclaurin series. So what he is asking is the tan inverse of x. So what you have to do? Now you know f of x is tan inverse of x. So any series is asked, first you find out some differentiation. First and second, tan inverse of x differentiation is 1 by 1 plus x square. Okay. Now we can also write 1 plus x square whole power minus 1. Now we have to find subsequently f double dash of x. So we can also write this one as 1 minus x square plus x power 4 minus x power 6. Okay, something like that. So f double dash of x we can write as minus 2x plus 4 x cube minus 12x. Then f triple dash of x we can write as minus 2 plus 12x square minus 12. Okay. Sorry, here I have written wrongly. Sorry. So f double dash of x will be minus 2x plus 4x cube minus 6x power 5. And f triple dash of x will be minus 2 plus 12x square minus 30x power 4. So now what you do is Maclaurin series is very easy. So what you do in Maclaurin series, you have to apply x is 0, get the value and apply in the formula. So in Maclaurin series, f of x, I will write f of 0 plus x f dash of 0 plus x square by 2 factorial f double dash of 0 like that, and x cube by 6 3 factorial f triple dash of 0. It is third order differentiation. So f of 0 is, if you have find f of x and you have substituted at x is equal to 0, then you would have got some value. And similarly, f dash of x and substitute as 0, then you would have got some value. Substitute it here and you will get the final value. This is what is Taylor's theorem is all about. So some questions are expected from Taylor's theorem and Maclaurin's theorem. And we may have to see the Taylor's theorem for a function of two variables and Maclaurin's theorem for the function of two variables in the next class. Please practice more problems in Taylor's and Maclaurin series. So in just, if you want to tell me, Taylor series is a series having a function which is dependent on h, which can be expanded in the power of h and can be differentiated in any number of times. So you can do a Taylor series, and wherever x is there, if you put a, then is the corollary f of a plus h. That series is the corollary of Taylor series. Now wherever a is there, you put 0 and h is there, you put x, then it will become a Maclaurin series. So Maclaurin series, for finding, if a question is targeted on Maclaurin series, take the f of x, find out f dash of x, f double dash of x, and up to third order differentiation, find it at x is equal to 0, then substitute in the series. If it is asked in the way of Taylor series, try to find out the x and h. We had a problem. We were asked to find f of 11 by 10. So we separated into 1 plus 1 by 10, x and h. Then it will be easy to solve the Taylor series problem. There are many exact problems with Taylor series and Maclaurin series. We will discuss in the future classes. Thank you.